Hey guys, this is Abhay Sharma, and in this video I want to show you a simple demonstration of few nodes I've been developing in animation nodes to handle camera animations, particularly on spline curves. This is still in development and I have developed this thing to help me out in my workflow. Normally people like to use camera rigs, but I always animated my camera on curve paths, and I wanted something which can handle a lot of repetitive things with ease. So currently this thing works on latest experimental build of Blender 2.79, which uses Python 3.6. Okay, and it is based on Animation Nodes 2.1, so that you won't miss out the new features of Animation Nodes. So the installation process is exactly the same as Animation Nodes. Before we get started, I want to thank Jax Luke who helped me out throughout the process. So Jax Luke, thank you so much. Currently, TPCam is not accessible through the menu system, so you have to use search box, which you can open with Ctrl plus A key. TPCam 0.1 is the main node, and it has two modes, simple and spline data. Simple mode is yet to be implemented, but spline data mode is working. First, let's select our camera here and turn on show limits, which helps you to visualize near and far clipping planes and also focus point. When you open the search box, you can access all the TP camera nodes by typing the TP space. All the nodes related to this TP cam have TP prefix. So let's create a TP spline node because we're gonna animate our camera on curve. Create a Bezier curve and select it in spline data node. Let's give it a duration of 20 frames and let's set the timeline range to 50 frames or so. Now if I scrub the time parameter, you can see camera is animating a long path. Let's create a time info node and connect it here. If I play the timeline, you can see it's animating. So now I want my camera to be facing the cube in the center. So let's create a TP camera data node and connect it with TPCam. Select the cube as our tracking object. Now camera is facing in the right direction. Let me move this a little bit higher. Now we are going to set the focus point. If I go into the wireframe, you can see my focus point is currently at the origin of the cube, because right now use track object as focus is selected in camera data node. I can go in N panel and turn on few settings related to focus. There is a focus object option if you do not want to use tracking object as focus. If there is no tracking object and no focus object selected, it uses the manual focus. Okay, so it's at the center of the cube, but I like to move it a little bit outward so that it's close to the surface. Because when we are this close to the subject, it matters. We can use shift focus for this. So let's try to adjust it. Something like this. The good thing is it sticks there. Doesn't matter if you move the camera or the tracking object. Frankly, I don't know how much it is going to be useful for you guys. It's just based on my random ideas. So let me know, what do you think? Alright, so you probably noticed that I am using two sockets for the same data type. One for single object and one for list, even though Animation Nodes supports vectorization from version 2.0. Well, as I said earlier, it's a work in progress. So let's talk about overshoot, noise, and global camera settings. If there is no camera settings node attached to the TPCam, you can modify camera settings in the Blender as usual, except for focus distance that's being controlled by the TPCam. But if you create a camera settings node and connect it to the TPCam, few of the main settings you can control right inside animation nodes. Let me create a new window here where I can see my camera view. Let's talk about Overshoot. So if I create an Overshoot node and connect it here, you will get the overshoot effect on camera position. It's not 100% accurate, but it works. You have to play with the settings to make it look right. For this example, I'm not going to use overshoot, so let me delete it. Instead, I will use a smooth ease out movement. So let me unhide interpolation from the end panel for the spline data. Let's choose cubic from the drop down menu, and you can see it eases out the movement. You know what, I'm going to create a different Bezier curve for my camera, so let me quickly create one. Something like this. Let me select this one as our curve object in spline data node and delete the old one. But there is a problem. I want my camera to come closer from farther. So clearly spline direction is wrong. We can easily switch the direction in edit mode, select everything, press the W key and choose switch direction. Now it's correct. Let me try to make it look a little bit interesting. Okay, let's add some noise. So create a TP noise node. We have three noise controls: location noise, track noise, and roll noise. For location, I'll use a vector wiggle node. Let's connect the time to evolution so that it can animate, but this is too much noise. First, let me increase the duration of the animation. Also activate the ease in so it's nice and smooth. Now let's connect vector wiggle to location noise and turn down the amplitude to something acceptable. Let's create one more vector wiggle for track noise. You can see now our track object is not in the perfect center. It helps to make it look a little bit more realistic, but it's too much, so let's dial it down. Let's add a number wiggle to roll noise to give our camera a little bit of random rotation in its Z direction. I need to increase the amplitude. It's in the degrees, so let's add 30 degrees of random rotation, plus and minus. It's too much, but I am exaggerating the values to make it more noticeable. Let's turn it down to 15 degrees or less. I think that's all I want to show you in this video as far as the TPCam is concerned. I don't want to make it look complicated. Frankly, it gets really messy very quickly. There is one more feature I want to show you, but before that, let's make this scene a little bit interesting. I'm not explaining each step here. Hopefully you already know these things. So I have added a displacement modifier here and animated it for 100 frames. I am adding some particles. It helps you to visualize the motion a little bit better, and I'm using an icosphere as my particle object. Disable gravity. I don't want my particles to fall down. Let's add a HDRI image. Activate render preview. Nothing is visible now because, so let's increase the f-stop value other than 0. It's black because we are inside the particle cube object. We have to hide it so that light can enter into the volume. In the particle settings, turn off emitter in render group, but it's defocused. Why it's defocused? Let me check. Focus point has shifted because displacement modifier made the cube smaller. So let's adjust the focus with shift focus. Let's add some surface properties to this thing. Alright, so let me show you that cool feature I was talking about. It's called fake autofocus. If you have already used a DSLR camera, you probably know what I'm talking about. Basically, when camera changes its position relative to the subject, it tries to refocus depending on the situation. We see this kind of effect, and this feature tries to mimic that one for one time. So let's say I want to trigger this effect somewhere right here. Let's unhide fake autofocus properties. I'll set the FA interpolation to cubic to make it nice and smooth. Turn on fake autofocus, and let's try this frame. So I'll enter 35 in FA delay. Now we have to tell what will be the duration of this effect. Let's try 20 frames, and if we go halfway through the effect, so 35 plus 10 equals 45, we can adjust the pullback option, which basically shifts your focus forward or backward. Let's say 3. Now if I scrub the timeline, you can see the effect. So we came closer to the object, then try to refocus, and now let's add a little bit of zoom to see the surface details. In this case, it doesn't have any surface detail, but you get the point. So we're gonna animate the focal length. Let's do this with animate float node. First we need time info. Then I'll change the start value to 50, which is 50 millimeter. Then connect the result to focal length. Duration of 20 frames is fine. Change the end value to something like this. But this starts animating from the beginning of the timeline. So let's add a delay time node and change the delay to 60 so it starts from the frame 60. Let's take a look. Okay, now we have to animate the f-stop as well because the depth of field is very shallow here. Let's try 1.0. That looks okay. Alright, we are done with the TP cam node for this video. Let's just try to beautify the scene. So I'm gonna play with the materials and stuff. How about we add a little bit of subsurface scattering? We can also use wireframes to make it look more interesting. Let's add material to particle object as well. Hopefully you like these new notes and maybe enjoyed the tutorial. So that's it for this video. Let me know what do you think. Let me show you the rendered result before we end the video. So this is how it looks. I have made another version also. Alright, thank you so much guys for watching this demo video. Try the add-on and please give your valuable feedback. In the next video, I'll be showing you how you can use it with multiple curve objects and with multiple targets. Until then, have a good day.